Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at advanced transformations of functions. We're going to look at these four types. Now, they're not transformations in the strictest sense. They're not geometric transformations. They are function transformations. What I mean by that, they don't do what we're used to. We're used to seeing transformations of functions either translate, reflect, or dilate a function. These four don't do that. They all do things in weird ways. So let's look at them one by one. So let's start with the absolute value of fx if this is the graph of f of x. Now clearly this blue graph constitutes a function. It would pass the vertical line test. Now when I want to transform from this graph to this graph, the main thing I need to do is mirror any negative y values. So what do I mean by that? Well, you can see that y values are negative in this region of the graph and in this region of the graph. So they are going to get mirrored. Now our mirror line is the x-axis in this case. So this part of the graph here is going to go up there. And this part of the graph is going to go up here. It's going to be a perfect mirroring, so this minimum here of -1 is going to move up here and become a maximum at +1. Okay, but what is the graph going to do in this region and this region? Well, in both of those regions, the y value is positive. When we take the absolute value of a positive number, we don't change it. So the y values here and here are going to stay the same. In those regions, the graph will look exactly the same as the original. So it'll go like this and like this, and we're done. See, this is all because we've just replaced y with f of x. This is just taking the absolute value of the y coordinate. So when you're graphing a transformation of this form, every time the y value is negative, you make it positive. Every time the y value is positive, you just leave it exactly as it is. All right, let's now turn our attention to this type of transformation. So here we are essentially taking the absolute value of the x coordinate. Once again, if you take the absolute value of a positive, it doesn't change the number. If you take an absolute value of a negative, you just change it to positive. So the right half of the graph, this part here, will stay exactly the same, because we're just taking the absolute value of a positive number. It won't change the input of the function. Now let's look at what happens over here. So if we were to say take the absolute value of this x coordinate, we would get +1. This has the same value, y value that is, as f of 1. So it will also go through this point. But what would happen to the input of the function of this point? Well, this has a negative x value, even though we don't know what it is. So the input of the function will change to the corresponding positive input. It will be down here at -1. What about the x values at all of these points? Well, the x values along here are negative. So the input will change from being negative to positive. So whatever the x value is here, we're changing it. So instead of using this input, we're using its corresponding input that's positive. So you can see that the graph is going to come up here, then it's going to go down to this minimum up here, and it's just going to keep going. So you can see that to start with the blue graph and end up with the green graph, we can just take the right half of the blue graph, right half of f of x, and just reflect it about the y-axis. Turns out that f of the absolute value of x is always an even function. All right, let's now turn our attention to this one, which is a bit more complicated. So the key point when graphing 1 over f of x is that x-intercepts of the original function become asymptotes of the transformation. For those who don't know, an asymptote is a line that the graph gets infinitely close to but never hits. It's like a no-go zone for the graph. So here, for f of x, the x-intercepts are -1, 0, and 1. So they become asymptotes when we graph 1 over f of x. So we're going to have these vertical lines here that our transform graph will never be able to hit. So we're essentially dividing the graph of our transformed function into 4 parts. So let's start looking at this part over here. In this part, f of x is negative, so 1 over f of x will still need to be negative. So for our transform graph, it's going to have to lie under the x-axis. Now, notice this graph is always increasing in this region. That means as x values increase, as you go to the right, the y values are going up. Now, the 1 on f of x completely flips that on its head. So for our transformed graph, it will be constantly decreasing. Now, it can never equal 0. You can't have 1 divided by something equaling 0. So we need to draw a graph in this region that is decreasing, gets closer and closer to, but never hits 0. Furthermore, it can never actually hit this asymptote. It gets closer and closer to it. So it's going to end up looking like this. So that's just that region of the graph. Now let's look at f of x in this region of the graph. So clearly it has a maximum of 1. So similar to what we saw before, this transformation will change that into a minimum. 1 over 1 is just 1. So the transform graph will still go through this point, but it will be a minimum instead of a maximum. Once again, we know the function will get closer and closer to, but never hit these asymptotes. Because it's a minimum, we know it's going to go like that. So second region of the graph is done. Now let's look at f of x in this region. Well, it's kind of just a mirror of what happened here. Here we have a minimum. Now 1 over negative 1, 1 over f of x is still negative 1. So it's going to hit this point here. But it was a minimum in f of x. Now it's going to be a maximum. It's still going to avoid these asymptotes. It's going to go like that. And you can probably tell that for this region of the graph, it's sort of going to do the opposite of what happened there. See, in this region, fx is increasing, but it's positive. So our transform graph is still positive. 1 divided by a positive is still positive, but it needs to be decreasing. It can never hit this asymptote, and it can never hit the x-axis because 1 divided by a number can never be 0. So it's going to look like this. So you can see that our transform graph, which is 1 over f of x, occurs in pieces here because this is a complicated transformation. All right, let's now look at the graph of the square root of f of x. So there are 2 points we need to consider. First, let's look at what I mean when I say the negative y's disappear. See, you can't square root a negative number. This is telling us to square root the y value. So if y is a negative number as it is here and here, we can't square root it. So these regions of the graph will just disappear. We don't even need to consider them. So let's look at what happens when the original y values were positive. So what happens when you square root a positive number? Well, if you square root a number greater than 1, you make the number smaller, often quite a bit smaller. So the y value of the original function was 1 at this point. All of these y values are more than 1, so square rooting them is going to make them smaller. Consequently, beyond this point, this graph, this transform graph that I'm going to draw in green, is going to get larger, much smaller than the original graph. So it's going to look like this. On the other hand, if you square root a number that's between 0 and 1, you make the number larger. So the green graph is going to have larger y values than the original graph in this region here. So it's going to look like this. You can see that the green graph has a higher y value than the blue graph for these x values along here. So as I said before, we're going to forget about this region of the graph because you can't square root a negative. Let's turn our attention here. Well, in this region of the graph, all of the y values are 1 or lower. Now, of course, the square root of 1 is still 1. The square root of 0 is 0. But what's going to happen is when we square root any of these y values between 0 and 1, you actually make the number larger. So the green value is going to be above it. It's going to look like this. So again, this function is in pieces, but that's our final function. Again, we've disregarded these two regions of our original function f of x because you can't square root a negative. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.